Alright, so in this lesson what we're going to be looking at are double replacement reactions. And so in contrast to single replacement reactions in which one element kicks out another one that was in a compound, in a double replacement reaction you have two compounds that react and they actually exchange partners. So what we're going to do is we're going to look at an example in order to understand how to predict the reactants and the products for a double replacement reaction. So in this problem, it tells me I have copper 2 nitrate and it reacts with copper 3 chloride. So I'm going to write these formulas. So copper's charge is +2, nitrate is -1, and so the formula for this would be CuNO3 Now that's going to react with iron 3 chloride. So again, I cross my charges and I would get FeCl3. And now I've got to figure out what my products are. So the rule for double replacement reactions is that cations and anions form together. So you're going to form a compound with a cation and an anion. Now, the way to make sure you do that is what I call innies and outies. Okay? So your outies in this case will be copper and chlorine. So I'm going to cross copper and chlorine. And then my innies are going to be iron and nitrate. And remember, your cation is always written before your anion. So I'm going to cross copper with chlorine. Copper's charge is +2. Chlorine is -1. So I would get CuCl2. And my other product is going to be iron and nitrate. Now, iron's charge is +3. Nitrate is -1. So I get FeNO3. Now all I have to do is balance. So I see that I have 3 chlorines and 2 chlorines. So to make those equal, I'm going to make that 6. So I'm going to put a 2 in front of iron 3 chloride and a 3 in front of copper chloride. And then a 3 in front of copper nitrate and a 2 in front of iron nitrate. And I am now balanced. Okay? So that's one step for a double replacement reaction. Now we're going to take it a step further. And we're going to look at the solubility rules for these compounds. If a compound is soluble, what that means is that it dissolves in solution. If it is insoluble, that means it does not dissolve in solution, so it's going to stay a compound. Okay? So for example, if I look at copper nitrate, I look and see nitrate. All right, I look at my table and it says for nitrates, NO3, that compounds containing the following ions are mostly soluble. Nitrate is one of those. But notice it has no exceptions, which means nitrate is always soluble. So I'm going to write soluble on top of that, because I'll use that information in just a second. Now I'm going to look at chloride. Okay, Cl- is soluble except when it's paired with silver, mercury, or lead. Well, iron is not silver, mercury, or lead, so therefore that's going to be soluble. Okay, copper chloride, again, is going to be soluble because it's not one of the exceptions, and then iron nitrate is going to be soluble because nitrates are always soluble. So what I can do now is I can take this double replacement reaction and I can write the full ionic reaction. So anything that's soluble I break up. So the first thing I'm going to break up is copper nitrate. Now copper has a 2+ charge, so when I break it up into its ions, I'm going to have 3 copper 2+ ions. Okay? And that's going to react with, well, I've got 6 nitrate ions because there's a 3 in front for the coefficient and then a 2 for the subscript. So I've got 6 NO3 minuses. Okay? And, well, iron chloride is going to break apart as well, so I'm going to have 2 iron 3 pluses and 6 chloride ions. Okay? That's going to produce, well, copper chloride is soluble as well, so 3 copper ions and 6 chloride ions. And then the iron nitrate is soluble as well, so I'm going to have 2 iron ions and 6 nitrate ions. Now, that's my full ionic. Notice everything broke apart. And so, to find my net ionic equation, what I'm going to do is anything that's the same on my reactant and my product side, I'm going to cancel out. And so what you should notice is everything cancels out, which means that there is no reaction. The net ionic equation, there's nothing. No reaction actually occurs. Nothing's going to form. Okay? So you've learned now how to write a double replacement reaction. You've learned about solubility rules. You've learned how to write your full ionic and then your net ionic. So let's do a couple more practices. In this case, I'm going to have silver nitrate reacting with iron chloride. So silver nitrate would be AgNO3. It's going to react with iron 3 chloride, so FeCl3. And that's going to produce, remember, innies and outies. So I'm going to do my outies first. Ag and Cl are going to combine together. Ag is +1, Cl is -1, so that would be AgCl. And iron nitrate. Iron's +3, nitrate's -1, so that's FeNO3. Then I need to balance. I'm going to put a 3 in front of Ag because I've got 3 chlorines on both sides now, and a 3 in front of AgNO3. Now I've got to use my solubility rules. Okay? So if you look back at that table, silver nitrate is soluble because all nitrates are soluble. So that's soluble. Okay? Iron chloride is soluble because it's not one of the exceptions. AgCl, if you look, chlorides are soluble except when they're paired with silver. Oh, there you go. So that's an exception, meaning instead of being soluble, it's going to be insoluble. Okay? And then iron nitrate, because all nitrates are soluble, that will be soluble. So let's write my full ionic. Okay? Silver nitrate is soluble, so I've got 3 silver ions and 3 nitrate ions. And iron chloride is soluble as well, so 1 iron ion and 3 chloride ions to produce, well, AgCl is insoluble, so I'm going to leave it alone. It's going to be just 3 AgCls. And my iron nitrate is going to break apart, so I have iron ions and nitrate ions. Okay? So anything that's the same on both sides will cancel out. So my iron ions will cancel out, and my nitrate ions will cancel out. So what I'm left with is 3Ag plus and 3 Cl minuses to produce 3 AgCl. So this is your net ionic. Notice there is a reaction here. And the reason why your net ionic equation is so important is it shows you exactly what is reacting. So in this big reaction, this double replacement reaction, the only thing that we really care about is the fact that silver chloride is being produced. And it's being produced because silver ions and chloride ions are reacting together. Okay? So another type of reaction that is a double replacement reaction involves bases and acids. Well, you know how to name bases because bases are just metal hydroxides, any metal with hydroxide behind it. Now, acids, however, we don't know how to name yet, so we're going to work on that right now. So, if I have an acid that has just an anion, like HCl, the way you name it is you write hydro, then the name of the anion, add ic to the end, and then acid. So for example, HCl would be hydrochloric acid. Okay? HI would be hydroiodic acid. Okay? If instead of just an anion, you have a polyatomic ion, which has an ATE ending, so SO4 is sulfate, what you do is you simply get rid of the ending and you add ic to it, no hydro needed. So in this case, you would have sulfuric acid. If you have a polyatomic ion with ite at the end of it, then you name the polyatomic ion with us at the end. So for example, if you have H2SO3, that would be sulfurous acid instead of sulfuric acid. So a trick that students last year came up with is that 8 is ic. So if you're, according to them, if you're with a big group of people, like 8 people, that's no fun, that's too many people. So 8 is ic, but us, just 2 of us, is ite, like all right, it's ite. So if you have an ATE ending, that's ic, us is ite. So for example, if you have phosphorus acid, phosphorus means you have PO3, 3 minus, because that's phosphite, not phosphate. Okay? So I'm going to cross hydrogen with phosphite. Hydrogen has a +1 charge. Phosphite has a 3 charge, so I would get H3PO4. So that's how you write the formula for an acid. So let's look at this example here. I'm told I have calcium hydroxide reacting with hydrobromic acid. So calcium hydroxide would be CaOH2, that's your base. You know how to write those already. And hydrobromic, remember hydro is when you just have an anion. So in this case, it's just Br with H. So it would just be HBr when you cross your charges. Okay? So this is a double replacement reaction, innies and outies. Calcium is going to form a compound with bromide, so it's going to be CaBr2. And then H and OH are going to combine together. Well, hydrogen's +1, hydroxide's -1, Notice that would just be HOH. Well, HOH is just water. So in an acid-base reaction, when you have an acid and a base, you form water and then an ionic compound. Now I need to really quickly balance. I'm going to put a 2 in front of my hydrobromic acid, and then I'm going to put a 2 in front of water to make sure I'm balanced. And that's all there is to it. So for these problems, guys, for double replacement, if I ask for your net ionic equation, make sure to write out your full ionic and your net ionic. For example, in this case, I didn't ask for that. I just asked for the double replacement reaction. So in that case, you can just write your double replacement reaction.